Hello friends, welcome to the that is a p block element, and up till to now we have already that is a study what is a p block element. P block elements are nothing but called as the element in which last differentiating electron enters into that is a p orbital, so it is called as a p block element. You can see here all these that is the elements are included as a that is a p block element. Okay, this is called as a p block element because the last electron enters here into p orbital. So this is known as a p block element. In this again p block element there are different groups classified as 13, 14, 15, 16, 17 and 18. As we have shown here represented here, this is a 13, 14, 15, 16, 17 and 18. 18 that is nothing but this element are known as the inert gas element. Okay, inert gas element, and elements these elements are non-reactive elements, so they are placed at the extremely right hand side of the periodic table ether. Okay, so up till this section up till to this section we already know that is how this p block element is again classified mainly in three types. That is three types are nothing but first that is called as metals, metalloids and that is the non-metals. Okay, so how this is a classification: metal, metalloids and non-metals. So these metals, metalloids and non-metals, you can see that the color notation is there. For metals, it is simply that is a light yellowish color ether starting from 13, atomic number 13. Okay, in stepwise 13 that is nothing but aluminum, gallium, indonesium, tin, bismuth and polonium. Okay, this is the what is the metals ether. And about this metal here you can see green color, which is nothing but called as metalloids. Okay, metalloids which shows metallic as well as non-metallic properties. And about to this position that is the pink color here, these all are the non that is the metals here. Okay, is that clear? Now how the exact location means position of an that is a p block is observed. Let's see the periodic table. This is our periodic table. Okay, in which we have classified periodic table in a group as well as in columns. Correct, these are groups. The number are given from 1 to that is a 18, and this is a periods which is given number from 1 to 7. Okay, is it clear for you? So to enlarge this, we can see yeah. Okay, that is the group numbers. This is the group numbers. Okay, from 1 to that is 18, and these are the numbers that is known as period numbers. Okay, but our that is a 13 group is starting of an pair that is the p block element, and in these 13 we can see here is a first that is a our 13 group elements. Okay, this is what that is exactly position means our atomic number 5. The element name is nothing but the boron ether. Okay, so this is what is the exact position of an that is 13 group element. Now in this which are the elements are it actually present. The elements are nothing but here basically for 6 elements are it there, sorry 5 elements we can explain it. Okay, that is nothing but first is boron, which has atomic number 5. Second, aluminium, which is atomic number is nothing but 13. Gallium, okay, 31. Okay, indium, that is a 49, and thallium, that is a 81. Okay, this is a element. Now, how to remember these elements? Simple tricks are either there. Okay, these elements are again represented by symbols. Here the symbol for the boron, capital B. Okay, aluminium, that is a Al. Gallium, capital G and small a. Indium, that is a capital I and small, and on thallium, that is a capital T with small l. Okay, how to remember this trick? There is a simple trick here. We can, that is a give as here bal, 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 G, that is a gallium. Okay, in Thailand. uh, did you understood? Okay, how to remember here? Here bal, that is nothing but boron and aluminium. G, G is nothing but it's a gallium. Okay, in, that is a indium, and thallium, that is a Thailand. Okay, so in this way, that is a simple trick is there to remember the 13 group element. Okay, because 13 group means periodic table is actually by-hearted in a group with them. Okay, so this is what is the simple trick to remember the elements either. Now in this, that is a trick again we are going to see. So this is what is the, that is a trick and even to remember the, that is the elements. Okay, now second in this again important concept, that is a to remember our electronic configuration. Okay, so to remember the electronic configuration, to remember this electronic configuration, we should know that is a here there again, that is a general configuration. So general configuration of an p block element is nothing but given as ns2 np126. Okay, this is what is the general electronic configuration of an p block element. Okay, out of which we are going to see our 13 group. For 13 group, I just have with the explain, it is the first position. This is the first position. So for this complete, that is a p block, general configuration is given as ns2 np, that is 1 to 6. Okay, okay. So this is what is the general configuration of an p block, and S2 and P 1 to 6 here. Okay, out of which we are seeing that is the first, that is a element, means that is the first group from the periodic table of an p block, that is known as 13. For 13 it is given as ns2 np1. Okay, is that clear now? Okay, this is what is the configuration of an 13 group here. Okay, so remembering this 13 group, again depending upon the period numbers, okay, in which there is exactly located, in which they are exactly located. Here you can see, okay, that is a boron. Okay, actually that is a present in second group. Aluminum in, that is the third group. Here you can see, okay, this is what is the position for boron, second group, aluminum, third group, gallium, fourth group. Okay, indium, that is the fifth, that is the thallium, that is the sixth, and deuterium means that is a new element is again to be discovered here, 113, which is the seventh period with them. Okay, so This is what is the exactly location. Now depending upon this location only, here configuration is given, means the outer energy. Okay, so boron period number is nothing but it the second. So his configuration start from 2s and 2p. Okay, second, third, that is nothing third period is nothing but the position, that is our aluminum, which has 3s and 3p. Okay, gallium 4s and 4p. So before 4 we know it comes, that is the 3d orbitals. Okay, and again, that is the fifth period, nothing but it the indium, which is nothing but 5s and 5p. Okay, thallium, that is a 6s and 6p. Before that 6 is nothing but either that is the 5 and that is the 4. Okay, 5 is nothing but d, 5d, and before that is the f, that is the nothing but that is the 4f ether. Okay, so this is what ether, that is a energy levels. Now according to, just we have with explained the general configuration of an 13 group is nothing but n ns2 np1. Okay, so you can see here in that is the ns, it contains 2s2, 3s2, 3p, sorry 4s2, 5s2, 6s2 in this way. Whereas in np1 you can see according to the energy level, that is the 2p1, 3p1, 4p1, 5p1 and 6p1. So in this manner we can give that is the energy level, and in this energy level the electronic configuration is also that is the given. Okay, so you can see clearly how that is the configuration is given. Is that clear? And to rewrite that is this configuration, again we use that is a inert element. Okay, because that is a here boron atomic number, that is a 5. The actual configuration is given as, that is the actual configuration is given as 1s2 1s2. Okay, out of 5 2 electrons are gone, still that is the 3 are remains. So after 1s it comes as 2s2 and 2p1. Okay, so as we go the down in the periodic table, okay, or in the group of an 13 group, the atomic number goes on increasing, thus that is the number of, that is the electron also goes on increase. As number of electron goes on increases, okay, the energy level also goes on increasing. This is what is the result. Is that clear? Okay, so this is we can explain the electronic configuration of an 13 group element. Now next variation, that is in 13 group elements. Different variations properties are there. Okay, first property we can say that is physical state. Physical state, just we have with that is previously only we have represented or explained all, that is the 13 group elements are that is classified in metal property. Correct? Now this is classified in a metal property, and obviously the metals are nothing but it the solid in state. So boron, aluminum, gallium, okay, boron, aluminum, gallium, indium and thallium are that is given in solid in state. Okay, this is a solid state. Second, that is atomic number. Atomic numbers are nothing and just we have given 5, 13, 31, 49 and 81. So how to remember these number also is very important trick here. Okay, we can simple, that is give the number in the form of, okay, so these are the number, atomic numbers. The second, isotopes. Each element has an isotope. Boron, that is a B11, okay, aluminum Al27, gallium, that is a Ga69, and indium, that is a 115, and thallium 205. 5 ether. Okay, this is a isotope ether. Now, depending upon these isotopes only, that is the actual atomic number, atomic masses are given. Mass numbers are nothing but the number of protons plus number of ether, that is a electron present in, and that is atoms ether. So depending upon that, atomic masses are ether given. And just now we have either completed the electronic configuration also. The electronic configuration of an each element is given as follows. One more time. Okay, important point is that that is atomic radius. Okay, radius, that is as we move from top to bottom, it is slightly, that is a decrease, again increasing in form. Means we can explain the atomic radius of an, that is the 13 group element, goes on increasing. Okay, increasing ether. Generally we can call it as a increasing, but actually we can say here slightly, there is a increase, again decreases. Okay, up to gallium, again it goes on increasing in indium and thallium ether in this way. Okay, so density also goes on increasing from top to bottom ether, that is the top to bottom ether. So depending upon this density, as density goes on increases, okay, the melting point and boiling point, you can either see it, that is slightly again goes on decreasing and increasing in the form ether. Okay, so this is what ether, that is actually variation of an 13 group element ether. Okay, so next, that is a general oxidation numbers ether. Oxidation number, for oxidation number we should know the electronic configuration. Okay, and here we have given the general electronic configuration of an all, that is a p block element groups ether. This is 13, 14, 15, 16, 17 and 18 in this manner. Okay, so here the general configuration of an each group is given as, for 13 group given as ns2 np1, 14 group is given as ns2 np2, 15 group given as ns2 np3, 16 group is given as, that is a ns2 np4, 17, that is the ns2 np5, and as usual obviously 18 group is nothing but ns2 np6, except that is for helium ether. Okay, the first member of these is nothing but boron family, means depending upon the first element, the element are either classified as boron family. Second, 14 group is nothing but carbon family. 15 group is nothing but nitrogen family. Okay, 16 group is nothing but oxygen family. Okay, 17 group is nothing but the halogens, that is we say halogens, and starting halogen is nothing but fluorine, that is fluorine family. And here inert gas element starting from ether, helium ether. Okay, and the oxidation number here is +3, and oxidation number also goes on increasing from, that is the left hand side to right hand side of an periodic table in period ether. Okay, it is not in a group. So in period, that is the general configuration oxidation number of an all, that is the groups, okay, goes on increasing ether here. But we are studying about the 13 group. So 13 group actually shows electronic configuration of an, that is ns2 np1. Depending upon this electronic configuration ns2 np1, it contains in 2s. Okay, means ns 2 electron, and 2p means that is a np contains 1 electron. Okay, these 1 and 2 can easily donate because it is incomplete. Okay, to complete it oxide, so it can easily donate an electron. 3 electron donated, so the oxidation number will be +3. Okay, this is what is the simple oxidation number. Okay, remember this oxidation number, because depending upon the oxidation numbers only, the atomic numbers, sorry, that atomic number we can say that is a chemical property of a different reaction can be explained with because in inorganic reactions the most of the reaction are explained on the basis of an electronic configurations only. Okay, that is we can again classify. So studying that is the next to the property called as the chemical property of an that is 13 group element. So chemical property of an 13 group element in which we are to see that is the first property means chemical property called known as action of an ether air. Okay, generally boron is inactive means in reactive in that is the crystalline form ether. Here we can given, okay, means what, boron in a that is a in reactive or unreactive in that is the crystalline form, but whereas boron in amorphous form and even aluminum in amorphous form are reacted easily with air. Due to this reaction only here 13 group elements are simple represent as either E, capital E, which reacts with oxygen, that is the oxygen, and forms its a different oxide. Okay, here oxides of an 13 group is given as a formula E2O3, whereas E is nothing but the our elements which are given as here barium, sorry, boron, aluminum, gallium, indium, and thallium ether. Okay, whenever these 13 group element reacts with oxygen, it forms an oxides as, okay, that is the E2O3. But that whenever these oxides are in the form, the oxide that is a property, oxide property goes on, that is the decreasing. Here we can show you the table form in the tabular form also. That is the when boron reacts with oxygen, it forms an ether boron oxide. Okay, that is which is nothing but weak acidic in nature. Okay, it is a weak acid ether. Whereas aluminum and gallium oxide forms as the amphoteric, that is oxide which is nothing but acidic as well as basics oxides are the form ether. Whereas indium and thallium, okay, it also form an ether that is oxide, but these oxides are the weak oxide ether, means basic in oxides ether. Okay, so this is what is that is the general chemical property of an first that is a property of an 13 group element which reacts with the oxide ether. And these oxides can also be classified here. We can show acidic property. First means boron boron oxide form an ether acidic property, and this acidic property goes on ether that is increasing ether. Okay, from ether that is acids to strong base one. Okay, this is what is the simple formation of an different oxides of an 13 group element ether. Okay, so our next section for this nothing but ether that is the reaction towards halogen ether. Here instead of ether halogen it becomes as a hydrogen, is a halides. Okay, now generally halides is represent as ether x nothing but has ether -1 charge ether. Okay, and 13 group element has ether +3 charge, means it become it act as a donor, whereas halogen act as a acceptor ether. Halogen accept that is 3 electron ether, correct now. Okay, so in this way depending upon the charge valencies ether, the charge valency are not balanced, so the 13 group element gains and 3 electron from an that is a halogen ether. Okay, and forms that is as ex3 in a solid form ether, and here x is as usual that is known as halogen, that is the fluorine, chlorine, bromine, and iodine ether. Okay, this is what is the that is the second chemical property of an 13 group element ether. Okay, now second property that is a chemical property means third property reaction towards the water molecules. When 13 group element reacts with water, yeah, it forms an ether, that is a hydroxide. Okay, hydroxide. But before that is starting any the formation of an hydroxide, metal hydroxide, that is a it is clear that boron is nothing but it's a solid form. Okay, it is a solid form, but boron in a solid form, that is nothing but in reactive, means in that is a dissolved in water. Here we can say that the pure boron does not reacts with water, whereas its amphoteric nature, that is a aluminum, and decomposes in water easily, okay, to form another aluminum hydroxide, nothing but AlOH the thrice ether, correct, OH thrice, with liberation of an hydrogen gas. So actually how this aluminum, that is aluminum reacts with the water, that is to study this reaction, first of all we know that is aluminum has the plus 3 valency, correct, like the means oxidation number of an aluminum is that is the plus 3, because just now we have explained for the 13 group, the oxidation number is nothing but the plus 3. Okay, and here the H2 molecule decomposes as H plus ion plus OH minus ion. Okay, so after that is this reaction, means ionization reaction, it is clear that aluminum has the plus 3 valency and OH has the minus 1 valency. Obviously that is a aluminum shows attraction toward the OH minus ion, means it gains an the OH minus ion, but as the valency purpose 1 minus and plus 3 are not balanced. To balance this reaction it requires 3 moles of an OH. So to contain 3 moles, again H also contains an 3H plus ion. Okay, so these now 3 moles of an OH minus ion, 3 moles of an OH minus ion are migrated to the H plus ion to form simple Al, OH, and as per the balance purpose thrice ether. This is what is the balance form ether reaction, and it liberates hydrogen gas in H2. Okay, so to balance this equation again, H2, that is a we have taken, that is a 3 moles, and OH also considered as a 3 plus 3 is nothing but the 6 moles here, that is the for 1 aluminum it requires 6 moles of an ether water molecules, which forms an aluminum hydroxide with liberation of an 3 moles of an hydrogen gas. Is that clear? Okay, this is what is the simple reaction for the aluminum, whereas gallium and that is the indium, okay, that is are attached by the pure and cold water only, it remains as usual, whereas thallium are more reactive than it, that is the gallium, and forms any oxides on its surface only. Okay, so this is what is that is a chemical property of 13 group element towards water molecules. Okay, and last that is comes here anomalous behavior of an boron. Okay, so boron shows different property as compared to 13 group element. Why this shows another, that is the different property? First property we can explain here, boron is nothing but act as in the non-metal, means it is actually in a non-metals, whereas other element in a groups are metallic in property, means metals, and due to these non-metals only borons are not, that is the bad conductor of an heat and electricity, whereas all other elements are metals, so they are good conductors of an heat and electricity. As usual, again borons are ether, that is that is what you say non-metals. Okay, due to which the non-metals with the melting point and boiling point are much higher than of with the, that is 13 group element, means it's form an ether amorphous form ether. Okay, due to amorphous form that is the it shows melting point in the boiling point higher than all 13 group element. Okay. Second, that is the boron exists in that is the allotropic form, means it shows an allotropy. Allotropy is nothing but one element exists in a two different form, and these two different form are often in the boron. Borons are nothing but first, that is crystalline boron and amorphous boron. Whereas aluminum is a soft metal and that is does not exist in a different form. It only exists in a one single form. Okay. This is what is the boron ether. Again, that is the boron does not has ether d orbital, due to which it cannot form any ether. Higher molecules means that is the boron forms in the tetra halides only. The higher, that is the complex cannot be the forms ether. Okay, this is what is the simple, that is the conclusion of an, that is the boron which behaves anomalous from the ether group ether. Okay. Now, important, that is the concept physical property. So up till now we have with studied that is the different that is the property of an 13 group, and even we have with seen that is the anomalous is the property of an ether boron. So depending upon these only, okay, the physical property of an boron are explained as here. Boron is nothing but the non-metals and hard in nature ether. Okay. It also shows that is a black colored in solid form. Okay. Crystalline boron is harder than is the diamond, as is the diamond, and it is non-reactive with water also. That is the explainer. Whereas amorphous, that is a boron, are the more reactive than, that is hard, it means that is the solid ether boron. Okay. Melting point and boiling point of an boron is given as, melting point is nothing but 2453 Kelvin, while boiling point is nothing but 3923 Kelvin ether. Okay. Borons, as usual we explained, they are ether non metals, means which they are ether poor conductor of an heat and electricity. Radius of an boron is very small, that is 88, that is the picometer, and even its ionic radius is small as compared to other element in a group. And general oxidation of an, that is the only boron shows ether, that is a +3, whereas all other different elements where shows can show variables in oxidation numbers. This is what about the actual, that is the 13 group and 13 group, that is from which we are studied, that is the physical up till to physical property of an boron. Okay. So depending upon this property only, that is chemical property of an boron are again that is given. Okay. So chemical, what are the chemical property? First property, that is a boron. Just now we have with that is explained in the general property of an 13 only, that boron in crystalline, that is boron is unreactive with unreactive with, that is air. Correct. So again, that is the one action of an air, that is a crystalline boron is unreactive, but whereas amorphous form of an boron are reactive in nature, and these amorphous, that is a boron, reacts with oxygen here to form an ether boron oxide, as well as these boron can be reacts with the nitrogen and forms an ether nitride. You can see here, when boron reacts with oxygen, it forms an B2O3 depending upon the valencies. Okay. So what is the valency of an, that is the boron? Boron valency is nothing but +3. Oxygen valency is nothing but -2. So such number are multiple, that here boron generally considered as ether 2 electron, 2 3s are 6, and even oxygen, that is the 2 3 2s are 6. So comparing to this, here boron oxide is formed. Similarly, in that is a boron when react with nitrogen, boron has ether plus 3, whereas nitrogen has the oxidation number of minus 3. So plus 3 minus 3 combined to form an ether simple, that is the nitride called as the boron nitride, means nothing but Bn. Okay, this is what is the chemical property. First chemical property of an boron. Second, that is the action of an water. So here just now be the explained in the physical as well as in the that is the general property also, that pure boron means that is solid boron are non-reactive with water here. Okay, so there is a no any action of an water on boron here. Okay, next, that is a property of an chemical property, that reaction with nothing but alkalis are nothing but apply the, that is the NaOH or KOH ether. Okay, NaOH or KOH on reacting with, that is boron, means boron on reacting with these NaOH. How the reaction is again formed? The reaction we can explain here. NaOH split is in the form of Na plus ion and OH minus ion. Okay, out of which that is a Na plus is there, which is not reactive with, that is the boron, because boron is also, that is a solid metal ether, and Na is also solid metal and electropositive ion. Okay, so it cannot be formed, but whereas ether hydroxide, okay, boron on combining with, that is a sodium, it forms an ether simple sodium orthoborate ether. Okay, sodium orthoborate ether. Second property, that is a reaction with nitrogen. Nitrogen, just now we explained, that is boron on reacting with nitrogen, it forms an ether boron nitrate. Similarly, that is a boron on reacting with carbon, its simple form and ether B4C, which is nothing but ether called as boron carbide ether. Okay, this is what ether, that is the chemical property of an, that is the boron ether. Okay, now next property of an ether, that is boron, explained as, that is a reaction towards the halogen ether. As we, that is a explained general chemical property of an 13 group. Okay, for in 13 group only where we explain that 13 group nothing but ether E reacts with ether, that is the halogens, that is the X2, which form an ether EX3 molecule. How it is formed? We have explained in previous, that is a concept only. Same concept is again repeated in our ether, that is the boron also. Boron on reacting with halogens. Okay, halides are nothing but ether minus X charge, whereas boron has ether plus 3 charge. So these boron are easily combined with the halogens to form an ether, that is halides. Okay, that nothing but halides are called as boron trihalide, and halides may be, that is a BX, sorry, BX, BF3, BCl3, BR3 or BR3. Okay, whereas trihalide boron, that is the triiodide, act as a Lewis, that is the acid. Most of it, that is the trihalides of an boron act as a Lewis acid. What is the Lewis acid again? Lewis acids are nothing but that is we explain, Lewis acids are nothing but explained as the substance which donates and okay, the substance which donates an ether, that is the electron, okay, are called as ether, that is a Lewis acids. Okay, so Lewis acid, remember this point ether carefully. Now next important section, that is a reaction with acid. So while reaction with ether acid, we can explain that boron means in the solid form of an boron, that is the does not react with, that is with acid in a moderate, means that is a room temperature, but at a higher temperature it can shows action with acids ether at a higher temperature. So boron on reacting with nitric acid at a high temperature, it forms an ether boric oxide, means nothing but H3BO3. okay, H3BO3, which evolves an nitrogen dioxide, means NO2. Similarly, that is the boron on reacting with, that is oxidizing agent called as the sulfuric acid. It also form an boric acid, okay. At a high temperature, it reacts with a high temperature and forms an boric acid of H3BO3 and liberates sulfur dioxide. Okay, this is what is the chemical property of an boron. And similarly, that is next important, considering that is a different compounds of an boron compounds are mainly we can explain in the three form, that is known as the borax, Na2B4O7, Na2B4O7. This is a Na2B4O7 known as the borax, okay. First compound, second compound, that is nothing but boron, orthoboric acid. Just now we have the seen it is formed in the, that is our as reaction with acids, okay. Nitric acid and sulfuric acid, nothing H3BO3. And lastly, that is the third compound of an boron is a, that is the diboron, nothing but B2H6. It is also given as BH3 twice, okay. Both notations are in the same form. This is what about the simple update. Now we have the seen that is the compounds of an, that is the boron, okay. Later on that is the, we will see that is the